So, good afternoon. Hopefully things are better after the coffee, I hope. So my name is Luca. I work at ON.Lab. I take care of ONOS deployments. And today I want to give you some updates on the activities that we've done so far. But it turned out this. I don't think you need this to hear me, right? So yeah, I was saying some updates on the activities we've done so far and future activities that are moving forward. So this is the agenda for today. I will talk about actual ONOS deployments around the world, the new requirements that we've got, future activities, just a slide on core deployments, and then we'll move forward to the conclusions. Okay, motivations and goals for deployments. Why do we do that? So, first of all, our decision was to start with research networks. Why research networks? Because they need to run production network, but at the same time are fairly easier compared to commercial provider networks. At the same time, these guys, by their nature, they want to continuously innovate in their network and experiment new things, so they were the perfect fit for us to start with. The idea was to create a global SDN network around the world to demonstrate, of course, that ONOS works not only on mini-nets, which is great, but also on real devices. Provide the minimal set of features is layer 2 and layer 3 connectivity to users without any legacy equipment in the network core, but only open flow, pure open flow networks, and possibly also covering layer 0. And enable network and service innovation. So what we do basically is to deploy in the research network. We get the feedback from the operation guys. The feedback are translated into new requirements. And the new requirements become, of course, in over and over the next releases of ONOS, new features that are deployed again and again. Okay, so how many of you, by the way, are confident already have seen this kind of talk before about deployments? No one? Okay, just a couple of people from ON.Lab. Good. Okay, so let me tell you where we started our journey. It was quarter 1, quarter 2, 2015. We started deploying ONOS in the research network of Internet 2, US, South America, EM-Light, and Giant, and Consortium GAR in Europe. We then moved forward, quarter 3, 2015, Australia, ARNet, CryoNet announced the first production ONOS deployment to be completed by 2017. And a couple of months later, we deployed the layer 3 features running on top of ONOS, always in CryoNet. And moving forward, we connected also Taiwan with NCTU, and we created a richer topology to connect all the countries together that are now running a global SDN network. So at a very high level, how the network works. So each one of these green islands is a standalone autonomous system. It's a pure open flow network. So for each of them, there's a set of open flow switches from any possible vendor you can imagine, controlled by the cluster of ONOS. Okay. So the testbed are connected together through dedicated layer 2 circuits. I always say I don't care how you connect them. Sometimes it's an Ethernet over MPLS, sometimes it's a VLAN. As long as you arrive to the first open flow switch at the border here with a clean layer 2 Ethernet. Okay. Over the layer 2 circuits, we do BGP peering, thanks to an ONOS application called SDN-IP. So as I said, each one of these is a dedicated autonomous system, standalone autonomous system. They exchange routes at layer 3, and then in each island, they do different things depending on the needs. So this is just to give you an idea of the applications that have been deployed till now. So SDN-IP and VPLS are two applications developed originally inside ON.Lab, but fortunately today we have other institutions like NCTU, Giant, and so on that contribute a lot to developing these applications. So VPLS, you'll see a demo tomorrow at the Brigade demo. it's a very simple application. So it started from the concept of, I want to do a very basic thing in the network, not fancy stuff. Connect A to B at layer 2, which seems to me the minimum requirement for a network, okay? So what you do is you define different interfaces at the edge of the network, and you say these interfaces are receiving traffic on different VLANs. You can create a sort of, we call it VPLS, but a sort of virtual network. You give it a name, let's say Luca, and you say add to network Luca, interface A, B, and C. From that moment, that becomes a layer 2 broadcast domain where all the hosts connected to those interfaces are able to communicate together. On top of that, SDN IP for layer 3 services. So SDN IP basically transforms an open flow network into an IP transit network. So from outside, you look like an autonomous system. You talk BGP to outside, you look like a router. But inside, we transform, basically, we receive routes, and we translate the routes into open flow entries on the switches to enable the communication between different autonomous systems. But the big news of this year, I would say, is SDX layer 2, layer 3, and Castor. Not because they're very different in terms of functionalities from the other two applications, but because these two have been developed and deployed by the guys of the research network. So imagine how powerful is this thing. Instead of waiting for the vendor to give you the new features, the new protocols, and so on, you just want your own application, your own functionalities in the network. You develop your application, you deploy it. Okay. So, all good till here. Let's talk about what's going on now. So, first of all, we are collaborating with different organizations in Europe in a 5G playground for the industry, so more industry-oriented. You can see the participants here. And it's basically a testbed to experiment SDN, NFV, and cloud technologies in a multi-domain, multi-vendor environment in the context of 5G. We actually already deployed there, gave the ability to the user to spawn ONOS instances on demand. So it's free, for what I know. You can go in the testbed and reserve ONOS instances for you and play with different devices from multiple vendors. So in the meantime, in the last 2 years, we had the opportunity to collect requirements from all the research networks we've worked with. The good news is that it seems everyone talking about the basics are all looking quite for the same thing. Simple solution that really works. And that's part of our job, get a minimal set of features that can work consistently in production. Minimal set of features for us means at least, as I said before, layer 2, so meaning VPLS functionalities, essentially, possibly compatible with the MEF standards for what is related to the industry, and for the research network with NSI for the multi-domain layer 2 circuit allocation. And then layer 3 for essentially internal and international BGP peering. On top of that, well, below that, possibly, on-demand Lambda allocation. Network slicing and virtualization are two new features that are coming out recently, and we are working on it. This is really the basic. On top of that, service provider, of course, they have more complex infrastructure, they have lots of legacy devices to deal with, so it comes in the game Yang, NetCom support, but also support the complexity that you find today in the central office. And that's how Cord, of course, came out these days. And as always, of course, maintain high performances, HA, scalability, and be carrier grade. Okay, so to be sort of production ready and work in a service provider environment. Okay, all these, I'm sorry, sometimes this slide confuse people. I don't really know how to put it together. These applications on top of ONOS should be side by side, but at the networking level, they go by layers. So that's why I put them on top of one each other. So you have, we say, VPLS plus carrier Ethernet application for the MEF standards plus BOD. Brigade is working with that to support NSI. On top of that, SDN/IP or Castor or SDX layer 3 slightly at high level are quite the same for layer 3 BGP communication, on top of a convergent packet optical network, all orchestrated by XOS, which is done. You didn't hear much about XOS this time, but is essentially a cloud orchestrator, always designed and developed and maintained by ON.Lab, and it's one of the basic components inside Cord. So all this translated into the work that the deployment brigade is doing these days. Okay, so what you will see, sorry, let me step back a second. What you will see in the demo tomorrow will be VPLS and SDN/IP working together. We are now working to integrate this over packet optical and possibly to let XOS orchestrate all the stack on top of that. So many of you asked about the Brigade initiative. So one more time, what's about are small teams working around specific features that we want to ship in upcoming releases of ONOS. Specifically, the deployment brigade has the goal to create a reliable software stack, a minimal set of features running on top of ONOS, easy to deploy and to maintain, to be used in production. So to be deployed, of course. Minimal set of features means layer 0, layer 2, layer 3 services to users, integration with widely used standards, and of course, as I said, deploy these in field trials, demo, but also in production. The brigade today counts 19 active members, all developers from academia, research network, and vendors. We have 33 members on the mailing list. Of course, all of you are very welcome to join us. Work has been done, the new application, the new VPLS application, plus having VPLS and SDN/IP that work for the first time together on top of the same ONOS instance. And I guess the Brigade work has been very powerful. All the work that has been done in about a month or so altogether. So the hope is that in 1 year we will be able to arrive more and more far. So what's future goals? It's not just about features, but we have more participants. And now that we have more features, we want to be able to deploy these features. So first of all, I'd like to move from the global SDN demo deployment, which is great, but it's something that you use just in demos, right? I'd like to start to focus network by network and put some minimal set of features in production. I want to hear someone that say, I run my real traffic, my real network in production. I think for certain features, specifically layer 2 VPLS, it's the right moment to go. So we can do this step. As I said, we are doing new things with actual participants. AM-Like, by the way, is already running ONOS in production for layer 3. We are also integrating the layer 2 services. We are making the new deployment on the new Internet 2 testbed, also putting here VPLS as an IP, and all orchestrated by eCore between multiple universities' websites. Kisti and Crionet, they will soon deploy also packet optical, and they want to have it in production by 2017. And we are doing a great work with NCTU in Taiwan, where they are working with VPLS, SDN/IP that have been already deployed, plus some more pod experimentation. And we have new participants. So I put the one in green. So I put Giant in green, not because we didn't deploy before, but because we were just working on their testbed. Now the idea is to start to experiment in the laboratories all the new software developed and to move it hopefully soon in production. We are working with the Israel Institute of Technology, deploying also VPLS, SDN/IP, and Cord. And finally, we are also deploying also in Japan on JGN-X, which will cover a great part of Asia. Just a slide, as I said, on Cord deployments. This is the ONOS Build event, but you know, since Cord was developed starting from ONOS, I thought it was good to mention it. So I don't know how much you are familiar with it, From the deployment point of view, we deployed Cord, of course, in our labs. We did the first field trials with some service providers. And we, as I said, we are also using XOS specifically, that component of Cord, to orchestrate Open Cloud, which is the Internet to wide area network deployment. So, conclusions. ONOS and Cord, as you all know, are out, are free, are open source projects. They have been quite extensively tested and deployed, even if much more needs to be done. We had a global SDN deployment powered by ONOS. We deployed over 60 OpenFlow switches, 12 institutions connected across 5 continents. We have validated different applications, and these applications are becoming more and more. Every one of us learned something from this experience. The good news is that everyone, well, at least a research network, is looking for the same basic solution, so covering layer 0, layer 2, layer 3, and possibly virtualization and slicing. Key to scale, bring in service provider and research network, the agile methodologies, and the DevOps models. This is fundamental. One of my biggest problems in my everyday job is to deal with Cisco guys, or don't take me wrong, if someone is from Cisco, but with classical network engineers. I know it's difficult, there's a lot to do, and it's a big change of mentality, but needs to be done. And finally, vendors. I can count maybe 1 or 2 vendors that today give me a great OpenFlow support. Every time we have a problem, all the pipelines are, of course, different. The support of OpenFlow and the features given to the users is completely different vendor by vendor. So what should be a standard at the end is not becoming anymore a standard, because every device is different from all the others, and this generates lots of problems. So future works to do. From demo, we will move to production. This is already happening in some networks like AM Lite. There are new apps, new deployments, new participants. We want to start to move from not only research network, but support also commercial deployments. An example, the first example is the 5G federated testbed. There's the deployment Brigade at work. You are very welcome to join us at any time. And as of course, as always, we will keep our focus on stability, performance, and scalability. Just to conclude, I left you some references here, and we will publish, of course, the presentation. Thank you. Do you guys have any questions? Yes.
I have a question about dependencies.
What?
The dependencies between the application.
Yeah.
So is it possible to use, for instance, VPLS with, here you say that work with SDN IP and LS3. But is it possible to use it with another component or application? So is it really independent from the layer?
Well, no. It depends. That's the right answer. So what we do is to combine them together in the network configuration. So the network configuration Andrea and Brian were talking about just before. Basically, SDN IP and VPLS, it's a longer discussion. Probably we should take it offline. But the high-level answer is they both look at the interface configuration part in the network configuration. And we have a way to distinguish interfaces that are owned by the SDN IP application and by the VPLS application. So we make sure when we read the configuration that both the applications don't interfere with each other. But that's something that it was done by design. So I don't know. It depends how the other application works, what flows does it use, and so on.
I saw that on the mailing group, sometimes you say you never test SDN IP with reactive forwarding. If you active some applications, it may not work. So.
Well, the fact is, with reactive forwarding, well, I know that's just an example, but I don't know how much sense it would make to run reactive forwarding and SDN IP together.
Just an example.
We will get to there probably when we will use intent domains more, because essentially you can divide your network in multiple areas. and control your network, different parts of your network with different applications. So that will happen. Otherwise, we always have ad hoc, let's say, ways to let applications interact. For now, the goal was, okay, we did all this nice demo of standalone applications working just for a demo. Now we need to have a real system. Real system means that you need to provide layer 3, layer 2, at least over a packet optical network. That's a decent stack that can be deployed in reality. And so we said, okay, let's start to think how we can put these applications together for the first time. But yeah, it depends example by example. We should talk about it. Any other question? Yes?
Is it possible people will have some type of relationship with ONOS or both?
I'm sorry?
Is there any possibility that there is some relationship between people with the...
Yeah. So Carmelo, yes. Carmelo is working on P4 to work on the integration of P4 together with ONOS. So definitely today you can do something. It's still not clear what can be deployed today on hardware, just because there are no P4 devices yet available out there. But definitely, as soon as there will be P4 devices available, we can support P4 already. Yeah. That's it. All right. Oh.
Another question. Can you clarify exactly the task of XOS with respect to ONOS? Why do we need both? Why it's not just ONOS?
So when I describe cord, I always say you have the arms that are for the compute, OpenStack in this case, and ONOS for the networking side. On top of that, you have the brain, which is essentially XOS. XOS is really an orchestrator, which tells at the right moment to ONOS what to do in the network, right? So in XOS, you really instantiate services, which are a composition of different things, including actions on your network. And those actions are performed by ONOS. In this case, the role of XOS will be to connect, basically on demand, multiple sites together. So eCord in this case can be used for connecting multiple central offices together, but it could be also to configure to connect multiple campus of the universities together and giving the resources to the users at the edge of the network. So that will be the high-level picture. Yes?
In your QC and material test, do you find some restraints or backward of the switch?
Sorry, I'm not sure I got the question.
Okay. You said that you had to put the QC and the material and the test with the open flow switch. The question is, do you find some backwards or restraints of this?
Backward.
Like some problems?
Yes.
Yeah, lots of problems. Of course, every day is a problem, but it's fine. I mean, it's natural, it's expected, right? That's one of the reasons we deploy, and we want to get the feedback. Of course, we started, if you think to the first deployment we've done in Q1, Q2, 2015, ONOS came out like a month earlier. So you can imagine how many bugs and how many things collapse every second, right? But with the first feedback we've done, the B release, the Blackbird release was better, and it went better and better moving forward. So I guess the first time it took like 2 months, 3 months to deploy ONOS on those networks. Like just having switches, controller already installed, putting SDN IP there, it took 2 or 3 months. Now it takes half an hour, 20 minutes. So of course, at the beginning, all the switches were not synchronizing correctly. Everything was going crazy. Everything was crashing. But then things went better. Yeah. All right. Thank you, guys.